Students, we are asked to find the value of I raised to the power 7, I raised to the power 1729, I raised to the power 1924 with a negative sign added with I raised to the power 2018, and then sigma n is equal to 1 to 102 I raised to the power n, and then you got a product multiple of I squared, I raised to the power 3, etc. It goes up to I raised to the power 40. So we start off by finding the value of I raised to the power 7. So these are the answers to the question. So I power 7 is rewritten as I raised to the power 4, positive 3. Always try to use the value of I raised to the power 4, which is equal to 1. Now I know a formula that a raised to the power m positive n is a raised to the power m times a raised to the power n. So using this formula, this is going to be I raised to the power 4 times I raised to the power 3. Now I raised to the power 4 is 1, so it's going to be 1 multiplied with I raised to the power 3. Now I raised to the power 3, I started by giving you the value for I squared, which is negative 1, I cubed, which is negative I. So this is going to be 1 multiplied with negative I, which is equal to negative I. So therefore, I raised to the power 7 is negative I. So this is the solution to the question. Now, having got the solution, let us move to the next question. So this is question number 2, which is I raised to the power 1729. Now 1729, if I were to divide 1729 by 4, 4 4s are 16, I got 1 here, 2, 4 3s are 12, I bring 9 here, 4 times 2 is 8, I get a remainder 1. So what I'm going to do, I'm going to write 1729 as 1728 positive 1, okay. So this is further rewritten as I raised to the power of 1728 multiplied with I raised to the power 1. I can always do this. Now this can be rewritten as, now 1728 can be divided by 4, 4 3 2 times. So this is going to be I raised to the power 4 times 4 3 2, okay, times I. Now this can be further rewritten as I raised to the power 4 times 432. This is the best way to write, multiplied with I. Now since I raised to the power 4 is 1, this is going to be 1 raised to the power 432 multiplied with I. Now this is going to be 1. So 1 multiplied with I would give me I. So therefore, I raised to the power 1729 is equal to I. Okay, so you can box that result. Now, having obtained the solution, let us move on to the next one. Question number 3, we are expected to find the value of I raised to the power negative 1924 added with I raised to the power 2018. Now this is rewritten as, if I were to divide 1924 by 4, 4 4s are 16, remainder 3, 32, 8 4s are 32, you bring 4, so it's going to be 481. So I can rewrite this as I raised to the power 4 times negative 481, okay, plus, now let me find what happens to 2018 when divided by 4. 4 5s are 20, you bring down 1, 0, you bring down 18, 4 4s are 16, so you have a remainder 2. So this 2018, I can rewrite it as I raised to the power of 2016 plus 2, okay. So rewriting this is going to be I raised to the power 4, the whole is raised to the power negative 481, okay, plus I raised to the power 2016 multiplied with I raised to the power 2, okay. Now this is 1, this is going to be 1, okay, 1 raised to the power of negative 481. Okay, plus this is going to be I raised to the power 4 raised to the power 504. Okay, because I've shown you here. Okay, if we were to have 2016, then it's going to be 504 multiplied with I squared. I'm not going to substitute the value now. Now this is actually 1 raised to the power, say, negative 2. If you say, for example, you have 1 raised to the power negative 2, this is going to be 1 divided by 1 raised to the power 2, which is eventually is going to give you a positive 1. Okay, now if it were to be negative 1 raised to the power of negative 3, or I would say positive 1 raised to the power of negative 3, it's going to be 1 over 1 raised to the power of 3. Okay, so what you actually see, no matter what this value is, okay, if it has got a negative exponent, okay, I mean, you can literally rewrite it in this fashion, right? Say, even if you were to have 1 raised to the power of, say, negative 7, I can literally bring it down, rewrite it as 1 divided by 1 raised to the power 7, and still you're going to get positive 1. So that is the idea I'm trying to show you here. So no matter what the value of the exponent is, it's not going to alter the sign of the quantity that you see here. So this is going to give you a positive 1. This is going to give you a positive 1, okay, multiplied with I squared, which is negative 1. So this is equal to 1, negative 1, which is equal to 0. So that is the solution for that question. Okay, students, we are given this question. N is equal to 1 to 102 I raised to the power n. We are expected to find the value of this. Now, the limit is stretching from 1 to 100. Now, 100 terms can easily be divided by 4, right? 4 times 2 is 8. So you carry 2 and you have 25. So you can actually divide 100 terms in parts of 4 and write them as 25 parts. But we are given 102. So that means if I were to write them in quantities of 4s, right, I would be left with 2 terms. So let me just show you what I'm trying to convey. So n is equal to 1, this is going to be the term. N is equal to 2, n is equal to 3, and n is equal to 4. So this is the first 4 terms, followed by the next 4 terms. N is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8. It goes on, right? N is equal to 97, n is equal to 98, n is equal to 99, and n is equal to 100. So clearly you can fit 100 terms in quantities of 4s, okay, like this. But you will be left with n is equal to 101 and n is equal to 102. Now let me box this off, we don't need this. So this is the representation. Now clearly all of these other 4 terms can be simultaneously rewritten as follows. In fact, I power 5, actually what is I power 5? I power 5 is nothing but I raised to the power 4 plus 1, which can be rewritten as I raised to the power 4 times I raised to the power 1. I raised to the power 4 is 1 multiplied with I raised to the power 1, which is nothing but I. So in fact, why have I done it like this, writing it in terms of 4? Because all the other terms, the second part of these expression, the third part of the expression, can always be written in the fashion of the first term, which is I squared, I cubed plus I power 4, owing to the fact which I've just shown you here. So the next terms are going to be I plus I squared plus I power 3 plus I power 4. So like that, you can continue on till you meet up with the I97, which is going to be I plus I squared plus I power 3 plus I power 4 plus the remaining I raised to the power 101 plus I raised to the power 102. Okay, this is I. So we have got terms like that. Okay, now just to reinforce what I'm trying to show you here is, say for example you take I raised to the power 97. Now I raised to the power 97 can be written as a expression in terms of 4. 4 divides 9 2 times and you get carried 1 over there, so that would mean you have 17. So 4 4s are 16 plus 1. So this is actually going to be 4 times 24 plus 1, right? Because 16 1 8 96 added to 1 would give you 97. So this is going to be the expression for I power 97. Now I have shown you that I power 4 times 24 can be rewritten as I raised to the power 4 raised to the power 24 times, there is a 1 there, so that's going to be I raised to the power 1. This is clearly 1, and this one has to be multiplied with I power 1, which is going to give you I. So that is exactly what I am trying to reinforce. So whenever you divide the list of quantities by means of 4 terms like this I have just illustrated to you, then clearly you can rewrite other terms which are coming after the first term as a form of the first term. So that's the exact understanding I want you all to have here. So this is equal to, now I is, you can't, there's not much simplification you can do with I, just write I as it is, but I squared is going to be negative 1 and I power 3 is negative I and I power 4 is positive 1. So this is what you get for the first set of 4 terms. The same would be repeating. So for this it's going to be I positive negative 1 positive negative I positive 1 for the second term, second set of terms, and so on it goes, and finally you are ending up with I positive negative 1 positive negative I positive 1. So this is what you get for the final set, followed by I raised to the power 101. Now 101, okay, I will reserve the simplification to the final part of the solution. So this is just going to be I raised to the power 101 positive I raised to the power 102. So this is what we have got. Now clearly I positive can be cancelled with negative and positive 1 can be cancelled with negative 1. So this is going to be 0. So all these terms are going to be vanishing. Okay, so we are left with I raised to the power 101 positive I raised to the power 102. Now if I were to use 4 and write 101, now 101 divided by 4, 4 times 2 is 8, you carry 2, you get 5, so you have an addition of 1. So this is going to be 4 times 25 positive 1. So I can rewrite this as I raised to the power 4 times 25 positive 1. Okay, positive I raised to the power, this can be rewritten as 4 times 2, 4 2s are 8, you carry 2, it's again 20, 4 4s are 20 positive 2 here. Okay, so this is rewritten as I raised to the power 4 raised to the power 25 times I raised to the power 1, this is for the first term, positive I raised to the power 4 raised to the power 25, okay, times I raised to the power 2. So this is what we have got. Okay, now this is going to be 1 raised to the power 25 times I positive, this is going to be 1 raised to the power 25 times I squared is negative 1. Okay, so this is 1 multiplied with I gives you I, this is 1 multiplied with negative 1 will give you negative 1. So you have what is negative 1 added with positive y. So what is this? This is a complex number. Okay, output is a complex number. This is a nice problem. You need to do questions like this to better enhance your ability of problem solving. So having given this, let us do the final question, which is I squared I power 3, and it goes on to I raised to the power 40. Okay, now we have to use this formula. A raised to the power m times A raised to the power n is A raised to the power m positive n. Okay, we know this, right? Now, so this entire quantity, say the first two quantity with this third quantity and so on, I can rewrite all of these quantities as I raised to the power 1 positive 2 positive 3 plus etc 40. I can do that. Now, you know, you should have this sum to infinity or sum to 10 terms. There is a formula that is given to us by arithmetic progression or arithmetic series. So if you have, say, something like this, 1 added with 2 added with 3 and up to n terms, then the formula is n into n plus 1 divided by 2. So I would be using this formula. So this is going to be, I got 40 terms, so if I were to use this formula, it's going to be 40 times 41 divided by 2. So that is what is the output for this entire quantity. So I'm going to use that. So that's going to be, so 2 divides 40 20 times, so it's going to be 4 times 2 41. So 2 ones are 2, 4 times 2 is 8, so it's going to be 820. So I have a quantity which is 820. Now I can use 4 and try to divide 820 by 4. 4 divides here 2 times, 4 2s are 8, 4 doesn't divide 2, so 0. 4 divides 20, it's going to be 5 times. So I can rewrite this as I raised to the power 4 times 205, which is going to be I raised to the power 4 raised to the power 205. I raised to the power 4 is going to be equal to 1. That's going to be raised to the power 205, and which is equal to 1. So that is the solution to this question.